Hi guys, welcome to my channel of Physics Infinity. In today's video lecture, we are going to talk about the case of two concentric metallic spheres. There are two metallic spheres of radius R1 and R2. Name them as X and Y. X is inner, Y is outer. They are given free charges Q1 and Q2 respectively. And of course, I have shown you three switches, S1, S2 and S3. Right now all the three switches are open. So both the plates are floating. I'm taking 3 points P1, P2 and P3. OP1 is X1, OP2 is X2 and OP3 is X3. Fine. I'll take at least 4 cases to discuss everything about the electrostatics of this case of two concentric metal spheres. The first case is when all the three switches S1, S2, S3 open. Then both the plates are floating plates. We'll discuss about the charge distribution, about the potential, about the intensity at different points, the capacitance, the energy pattern, everything that you can think about regarding this. You'll have everything in this video lecture. So here we are. Number one is the charge distribution. On X1 it is 0. It has to be in electrostatic equilibrium. Conductors in electrostatic equilibrium, there is no charge inside. On X2 it will be Q1 conservation, because Q1 is given to X, so X1 has 0, so entire Q1 will be on X2. On Y1, the inner phase, it will be minus Q1, Gauss's law, and on the outer phase Y2, it will be Q2 plus Q1. Charge conservation again, floating plate. Number 2, let's talk about the potential. Potential, first of all, for X. So Vx will be the potential due to X and the potential at X due to Y. Superposition principle. So KQ1 by R1 plus KQ2 by R2. Potential of Y. Potential at Y due to the sphere X and then to Y itself. Superposition principle again. Vy is KQ1 by R2 plus KQ2 by R2. So what is the difference of potential? Vx minus Vy. I am assuming Q1 is more than Q2. So, well, we are taking Vx to be at higher potential than Vy. It's just assumption because we are taking the algebraic expressions right now. So Vx minus Vy will be KQ1 1 by R1 minus 1 by R2. K is the electric field constant, 1 upon 4 pi epsilon naught. Epsilon naught is the permittivity of free space, which is almost same as that of air. Okay, let's move on to electric intensity, and I take 3 points P1, P2 and P3. P1 is inside X1. Of course, field has to be 0. If I take a Gaussian surface here, then of course field will come out to be 0 because the flux is 0. Let's talk about P2. So this is the Gaussian sphere. This is the Gaussian sphere. So at P2, E2 will be KQ1 by X2 square, X2 cap if I am taking in the vector form. At P3, it will be the whole charge, Gaussian surface here. So the entire charge is enclosed Q2 plus Q1. The field will be the contribution, flux will be the contribution from Q2 plus Q1. So E3 arrow is K Q1 plus Q2 upon X3 square, X3 cap. Fine. So that's about the field. We can talk about now the capacitance. Many students may think, oh, it is a case of two concentric spheres, and we have learned that in our school program, the concentric spheres capacitance is 4 pi epsilon naught R1 R2 upon R2 minus R1. But yes, this case, not so. Why? Because in that case, you earth the outer sphere. The field gets confined up to the plate Y, but not here. Here the field starts from X2, terminate at Y1 and then Y2 to infinity. So this is the case of two capacitors in parallel. One is C1 and the other is C2. C1 is Q1 and minus Q1. So that is formed by the plate, the surface X2 and Y1. This is 4 pi epsilon naught R1 R2 upon R2 minus R1. No problem. But the other is the case of a sphere R2 whose other plate is at infinity. Concentric sphere at infinity. Why? Because the field line starting from Y2 will terminate at infinity. So this will be C2, that will be 4 pi epsilon naught R2. I add the two, I get the net capacitance. You can do that exercise you can do yourself. Fifth thing, we talk about the field pattern. What is the electric field pattern? Sure, I start from O. From O to x1, the field is 0, so I don't show any line. Then nothing in between the metallic material, conducting material. Then x2 to inner surface, that is y1. Terminate there. So no field will be inside the conducting material. Then y2 to infinity. So that is the field pattern. Now the sixth thing that we are taking in this case 1, that is finding out the electrostatic potential energy associated with the system. Now mind you one thing, the electrostatic potential energy is stored up within the electric field associated with the system. The electric field is from x1, from x2 to y1 and then y2 to infinity. So I can find the energy by three methods. The method 1, I give you the self energy and the interaction energy method. Self energy of x, self energy of y, interaction energy of x and y. So q1 square upon 8 pi epsilon naught r1, q2 square upon 8 pi epsilon naught r2, self energy of y, interaction energy k 1 by 4 pi epsilon naught q1 q2 upon r2. Done. You can just add this up, you get the answer. Better to know it in parts like this. The second method we do by the capacitance method. Okay, U is energy stored by x1 by C1 and energy U2 and then energy U2 stored by C2. Q1 square upon 2 C1. C1 we have done 4 pi epsilon naught R1 R2 upon R2 minus R1. C2 4 pi epsilon naught R2. Put the values of C1 and C2, solve this simple exercise, you will get this answer. Same. Interesting? Very interesting. Third method. By three methods I teach you so that you become perfect in understanding the energy density and integration. Energy density. So U. So if I take an elemental volume, that is 4 pi x square dx and then use the proper limits of integration, I can do by the integration. Small u is half epsilon naught e square and the elemental volume I take spherical because there is spherical symmetry. So for that the elemental volume will be 4 pi x square dx. Fine. So u in the limits of integration will be x equal to r1, that is surface of x2 to infinity. But this I'll have to break up into two parts. First integration from r1 to r2 limits and then r2 to infinity. So half epsilon naught. Now within this the electric field is q1 upon 4 pi x square u and elemental volume 4 pi x square dx. The second part, x is r2 to infinity, half epsilon naught, and in that the field is as a function of x q1 plus q2 divided by 4 pi epsilon naught x square of that 4 pi x square dx. Now this is a very simple integration. Take out the constants. It's a simple integration of 1 upon x square dx, put the limits, 1 upon x square dx, put the limits, do that as an exercise and you will get the answer. So now you know everything about the physics of the two concentric spheres when both are floating plates. So once again we are with the case of two concentric charged metal spheres, but in this second case we have S1, the switches S1 and S2 are open, but the S3 is closed. When S3 is closed, that means the plate Y is no more floating, it is earth, so its potential will be 0. And now let's study all the different possibilities in density, potential, etc., energy, field pattern as we discussed in the first case. So there we are. First and the foremost thing, the charge distribution. While there will be no charge on x1, face x1, the charge would be 0, of course. On x2, it will be q1. On y1, it will be minus q1 by Gauss law. And on y2, it will be 0. Reason, this is Earth and y2 is a free face of the Earth plate, and after y2, there is no other charge body or there is no electric field outside, so y2 will have no charge. Let's talk about potential. As far as Vx is concerned, the potential due to x itself, so kq1 by r1, then the potential at the site of x due to the face x2, which has a charge of minus q1, so minus kq1 by r2. I use the superposition principle. And then Vy is of course 0, it is an earth plate, so Vx minus Vy is k q1 into 1 by r1 minus 1 by r2. K as usual is the electric field constant, 1 upon 4 pi epsilon naught. Epsilon naught is the permittivity of free space or that of air. Let's move on to electric intensity, and once again I choose 3 points. P1 inside the plate X, inside, that is less than R1, so it is within here. P2 is between the faces X2 and Y1, and P3 is outside. Distances are X1, X2, X3 respectively. So there you are. As far as the electric intensity is concerned, at P1, E1 is 0, no charge. There is no charge inside, so Gauss law will not give any flux and hence no field. At P2, E2 arrow is k q1 upon x2 square, x2 cap. So if I draw a Gaussian surface here, this will enclose the charge. This will enclose the charge q1, so I get the contribution from there. As far as E3 is concerned, the field will be 0 because at P3, if I draw a Gaussian surface, the net charge inside is 0. q1 and minus q1, 0. So the field would be 0. Now let's talk about the capacitance, the fourth item, the capacitance. Now here the capacitance will only be that of the concentric charge spheres, that is this one having x having q1 and y having minus q1 on its inner face. So the capacitance is just like what you learned it at your school level, in the board level, 4 pi epsilon naught r1 r2 upon r2. So now let's talk about the field pattern and the energy linked up with the electric field associated with the system. So here is the field pattern. From x2, from center to x1, there is no field, field is 0. Then from x2 to y1, it starts from x2, terminate at the face y2, no field inside and no field outside y2 as well. So the field gets confined, the field is radial and it gets confined within the face x2 and y1. That's it. Now once we know the field pattern, it is very easy for us to move on to the sixth item, that is electrostatic potential energy linked up with the field. Now once again we'll do the three methods: electrostatic potential energy U, the self energy and interaction method. So self of x, self of y's interaction, self of x q1 square upon 8 pi epsilon naught r1, self of y q1 square upon 8 pi epsilon naught r2, and the interaction q1 and minus q1 is minus q1 square upon 4 pi epsilon naught r2, that comes out to be q1 square upon 8 pi epsilon naught r1 minus q1 square upon 8 pi epsilon naught r2. Cool. Let's now move on to the second method, that is the capacitance method. The capacitance, you know, is C equal to 4 pi epsilon naught r1 r2 upon r2 minus r1. So the energy is q1 square upon 2c, and that comes out to be same. You just put down this expression and you will come up, you will get the answer same as 1. Leave that as an exercise to you. Third is of course the energy density and the integration method. So U is equal to U dV integral, and the limits of integration are from x equal to r1 to r2 where the field is confined. So half epsilon naught, now small u density, half epsilon naught e square. So half epsilon naught q1 upon 4 pi epsilon naught x square, square of that, and the elemental volume 4 pi x square, spherical distribution, so 4 pi x square dx. Simple integration, constants will go out and you have a simple integration of dx upon x square. You do that as an exercise. I leave that as an exercise to you, and enjoy doing that, and you will get the same answer as 1. So this brings us to the close of this second case of two charge conducting concentric conducting spheres. Regarding electric intensity, at P1, E1 vector is 0, intensity is 0. At P2, the field is due to small q, which we had assumed, and which is minus negative fraction of q2. So q upon x square x cap, I replace the value of q. So E2 arrow is minus k r1 upon r2 q2 upon x square x cap. At P3, I only have the contribution due to the charge on Y2, and the charge on Y2 is R2 minus R1 upon R2 into Q2. So K charge on Y2 upon x square x cap. Okay. Let's talk about the field pattern, because in the field then we'll talk about the energy and so on. Well, this is the plate X, this is the plate Y. On plate X, phase x1 charge is 0. On x2, it is negative fraction of q2. On y1, positive fraction of q2, and on this the balance of q2 charge here. So from y2 to infinity, radial field outward. Then from y2 to x2, y2 to x2, radially inward, inside no field. So that is field outside, y2 radially outward, and between x2 and y1 radially inward. The third case, in this case S2 and S3 are open, S1 is closed. This means the plate X, the inner sphere, the inner plate is earthed, whereas the switch S2 and S3 open. So what will happen now? Let's see. Obviously Vx will be 0, and then let's see first of all the different charges on the faces. Charge distribution. On x1 it will be 0 as usual. Now on x2 we have to assume, because it is a bound face of the earth plate, so let the charge on x2 be q. It's an earth plate, so q1 will have no meaning. Let the charge on x2 be q. Then on y1 it is minus q by Gauss law, and on y2, y is a floating plate, total charge should be q2. So therefore on the face y2 it should be q2 plus q. q2 plus q minus q gives you q2. To find q now what is the value of q? It's an unknown. To find this we need a condition, and we have a very important condition, that the plate X is earth, so Vx is 0. I use this. So 0 is equal to, now if I have to find the potential at X, superposition principle again, kq by r1 due to q on X, and kq2 by r2 due to total q2 on Y. This gives me q as a negative fraction of q2. Q is minus r1 upon r2 into q2. So it is a negative fraction of q2. Fine. Finally, what are the charges? On x1 0, on x2 minus r1 by r2 into q2. On y1 it is plus of that, so plus r1 by r2 into q2. And on y2, phase y2, it will be q2 minus this. So q2 minus r1 by r2 into q2, that is q2 into r2 minus r1 by r2. So now we know, once we know the charge distribution, we can then do anything. Find the field, potential, energy, everything. Okay, let's now find the potential. Vx is 0 anyway. So Vx is 0, it's an earth plate. To find Vy, I have to find the potential on the plate Y due to X, and then on Y itself. Due to X, it is kq by r2, it's an outside point, kq by r2, and due to the plate Y itself, it is kq2 by r2. So that gives me, okay, k upon r2 common, it is q plus q2. I put the value of q, so I get 1 up, and I break k because k is 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught r2 into minus r1 by r2 q2 plus q2 Just adjust that simple mathematics. So 1 by 4 pi epsilon naught R2 into Q2 into R2 minus R1 upon R2, that becomes Q2 divided by 4 pi epsilon naught R2 square, and above in the numerator R2 minus R1. So this is the potential, that is Vy. So technically Vy minus Vx, overall the potential or overall the charge on Y is Q2. So that's a higher potential, and on X of course the potential is 0. Let's now talk about the capacitance of this system. The capacitance, as we have seen, there is capacitance between X2 and Y1. Well, that's the concentric sphere. Let me call it as C1. So C1 is 4 pi epsilon naught R1 R2 upon R2 minus R1, and the second one is Y2 and infinity for the phase, spherical phase Y2 and infinity. So that will be 4 pi epsilon naught R2. So C2 will be 4 pi epsilon naught R2, and the two will be taken as parallel. You can add this 2 to get the effective capacitance. To find the energy, now as you can see here, there is field between these two, and that is radially inward, and then field from here up to infinity, and within this of course the energy is stored. And now since we have learned the concept of capacitance, let's do it by the capacitance. The other two methods by integration and others, I leave it to you. I've done it already in the other cases. You can try it out on this case. So U will be U1 plus U2. U1 is the potential energy that is within this field, and U2 is the energy that is in the field from Y2 to infinity. Well, I use the formula Q square by 2C. So for U1, the charge involved, the charge that I will take is fraction of Q2. So R1 upon R2 Q2 square divided by 2C1, twice 4 pi epsilon naught R1 R2 upon R2 minus R1, plus the energy in the outer field Y2 to infinity. The charge is on the face Y2, that is R2 minus R1 upon R2 into Q2 square divided by twice the capacitance, and for that the capacitance is 4 pi epsilon naught R2. Well, just solve this expression and you get the expression for the energy. Now we discuss the fourth and the last case, when S1, the switches S1 and S3 are open, but S2 is closed. Now when you close the S2, these are open, so forget about. When you close S2, then the plate X is connected to plate Y. Okay, plate X connected to plate Y. Well, this is just one conducting sphere of radius R2. So it just becomes one conducting sphere of radius R2. So this is the easiest case now. All charge Q1 will move to the outer surface of Y, that is on Y2. So all the charge Q1 plus Q2 will be on the face Y2, on the face Y2. No other face will have any charge. Potential of the conducting sphere, you know very well. So it is a case of a conducting sphere of radius R2 which is given a free charge Q1 plus Q2. So what is the potential? It's an equipotential surface, it is an equipotential volume. So the potential on the surface is K Q1 plus Q2 upon R2. Potential anywhere inside at P1, at P2, it is same. It will be an equipotential volume. So same value as this. For point P3, that is outside, we have already done that. The sphere will behave like a point charge lying at the center. So as if the Q2 plus Q1 is lying at the center. So potential at P3 will be K, will be, okay, I can just, it will be K Q1 plus Q2 divided by X. So that is about the potential. Let's talk about the intensity. Just like the intensity of a conducting sphere having a charge q1 plus q2. So field everywhere inside is 0. On the surface it's k q1 plus q2 upon r square, r cap, and outside k q1 plus q2, k q1 plus q2 divided by x square, x cap over. That's about the intensity. Field pattern, okay, the field pattern, no field from center up to y2, then from y2 onwards, well, the field varies inversely proportional to x square. So I will have the field starting from y2 terminating at infinity. Capacitance, capacitance of a single conducting sphere whose other concentric sphere is lying at infinity. So capacitance will be 4 pi epsilon naught R2. Energy, field pattern, well, I've already spoken about the field pattern, that is from y2 to infinity, well, inverse square fall, so spherical distribution and so on. Energy, well, the energy, this is a capacitance, its capacitance is 4 pi epsilon naught R2. So either you do by integration or by capacitance method, or even it has its self energy. So q2 plus q1 square upon 8 pi epsilon naught R2, or in terms of the capacitance it will be q2 plus q1 square, or q1 plus q2 square divided by 2 into c1. So 2 into 4 pi epsilon naught R2. Okay, and if you now do it by the integration, also again you will get the same method. Well, that brings us to the end of the story of the two conducting spheres. We have discussed all the cases threadbare, and I hope that from this you will have gained enough knowledge about concentric spheres. I'll now produce another video. That will be on 3 concentric spheres, and that of course is going to be tough, because I will sometimes earth the middle one, the first one, or the third one, and so many things, so many different cases will. So the complete story of the 3 concentric spheres will come up in the video ES-6. I hope you have enjoyed by this video and you have liked it. Please put a thumbs up. Please do subscribe. This is very, very important, and because only then you are going to get the notifications for my coming. I'm regularly making the videos, so you must be a subscriber, and that will benefit you. Thank you very much for listening, and all the best.
If you love the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.